at the all-new BSIDE ZT-M1 True RMS 8000 count multimeter that likes to do things a little differently. Let's check it out. The NV8 is the identical twin to the BSIDE ZT-M1. They are one and the same with just a different name. Alrighty, so what do you get in the box? Good question. First of all, you get the user manual, and as an added caveat, it is all in English. Get a pretty decent looking thermocouple or temperature probe, and we'll look at that later because this meter does have that cool dual temperature readout. And finally, get a fairly decent set of probes. At least they look decent, but we all know that looks can be deceiving, and we will find out just how good or not so good probes are. Get a decent little travel case as well. It's really not padded, but hey, better than nothing. All ships in a pretty decent looking box, and you know what? I think it's time to start testing. Going clockwise. NCV, or non-contact voltage. Square wave generator with an output 50 to 5000 Hertz. 1.5, 9 volt, and 12 volt battery test. Manual resistance range from 800 ohms up to 80 mega ohm. Volts AC from 8 to 750 volts. Volts DC from 1000 to 8. Temperature mode in both Fahrenheit and Celsius. Microamps, milliamps, finally amps, AC/DC. Continuity, diode, capacitance, resistance up to 80 mega ohm, frequency and duty cycle, millivolts DC, millivolts AC, including frequency and duty cycle, volts DC. Finally, VFC mode, or variable frequency, also known as low-pass filter. The 12 o'clock position, we have the off. Looking at the function switches, we have the select switch, the range switch, the VFC, also known as the voltage frequency converter, or low-pass filter mode. We have our rail over here, as well as a flashlight. This is the max-min, and finally the hold. Over here is a illuminated LED, and as you will see in action in continuity mode. Okay, so what about the fit and finish on this little beast? Well, this is where I am disappointed. Starting with the boot, it's it's a nice boot. I've got nothing wrong to say. It looks good. It has a nice durable feel to it. It's fairly grippy. Maybe it's a little on the slippery side, but hey, all in all, it's decent. Now this model comes in multiple colors. I just happened to get the black, but you do have a bevy of different colors to choose from, including hot red. Alrighty. Now if we take off the boot, this is where I have a bit of an issue with the build quality. For me at least, I get a very plasticky feeling, like a cheap PVC plasticky, I mean, it's really not a cheapo meter. This is like a $62 Canadian this cost, so it wasn't exactly cheap by any means. Yeah, for over 60 bucks, I don't know. Is it just me? Am I being too nitpicky? But honestly, I did not really appreciate the quality of the plastics that they've utilized in this production run anyway. Maybe it's just me, bad luck, but I see all sorts of little interesting marks on the plastic. And just generally speaking, it just kind of looks and feels cheap. So what makes this meter really unique is the fact that you have both the manual ranging as well as auto ranging. Now the manual ranging is not for every single range. It is only for resistance as well as volts AC and DC. So nothing to do with current and nothing to do with capacitance, what have you. But still, that is pretty darn cool to have this manual range attached to an auto range meter. Very nice. Two different camps in terms of what's better, manual or auto ranging. Honestly, I don't see a big difference either way. If you're a semi-pro or a professional and you just know what you want, you know what range you need, it's definitely going to be a little bit faster. Not always, but generally speaking, a little bit faster to range if you're in your manual mode. That being said, obviously, auto ranging is the way to go if you're a newbie or if you're just a casual user and you want to have a quick and easy measure. These valves are really nice, rubbery plastic, rubber, I should say, not plastic, and pretty tactile. The weight of the meter is all right. It's actually, I found it, believe it or not, a little bit on the light side. I thought it'd be a little bit heavier, but not bad. Okay, let's take the plastic off so we can get a good look at this gorgeous EVTN display. Oh yeah, so the nice thing about this display is the fact that it doesn't matter really what angle you're looking at. Well, no, I guess that one is a little off. Yeah, pretty well. Almost any angle, it is very, very nice. So yeah, hey, I like that screen. There's no way to adjust the brightness. Basically what you see is what you get. If we compare it with, let's say, the Q1, what do you think? Pretty close. Obviously the M1, the B-side, is bigger, but I think they're pretty well identical in terms of the overall contrast. So, hey, looking good. I'll start things off with a DC voltage precision accuracy test. And before we do that, I just want to say that these probes are actually quite nice. Fairly pointy, but really, really nice silicon. Was not expecting that. So definitely a step up from your average El Cheapo probes. And yeah, I hope they work as nice as they feel. Alrighty, here we go. Alright, we should be looking at 0.250 millivolts, and it looks like we're almost there. Next, we want to see 2.50 volts, and spot on. Manual range, we can go as low as 8 volts. And let's just compare that accuracy in the manual side of things. So we should be looking at, we're in AC mode right now, so we want to bring that to DC. Divide. And, oops, my God, I hate it when I do stuff like that. All right, there we are in DC mode. Hey, I just got the meter, guys. Give me a break. Ha! Alrighty, so we should be looking at 2.50 volts and identical with the auto ranging mode, 2.501. And we will put it back on the 250 millivolt. Spot on, 0.250 millivolts. We're in capacitance mode now, and this does have a 100 millifarad cap. And look at that, 99.13. And it was pretty fast. I will just do it again. And you see we have that indicator here, the LED kind of flashing, and it's giving us an OL now, saying you're out of luck, but hang on, there it comes, 98.93 millifarad. Good stuff. Next up, a 3.3 microfarad capacitor, and perfect. Finally, a 0.1 microfarad cap, and showing up as 107.1 nanofarad. Good enough for me. Let's try diode mode. Here we go, starting off with the green LED, 1.8 volts, and it is just barely illuminating. The yellow, no problems here, 1.8 at the forward voltage drop. Let's check out the red. Looks good. Over to the blue. And finally the white. Hey, love it. 5 for 5. Next up is a typical diode. Let's check out that forward voltage drop. And looks good. Reverse the leads, we shouldn't get anything. Perfect. The BSIDE ZT-M1 is pushing out 3.2 volts in diode mode. Next up, DC voltage comparison. I've got the Anning Q1 right beside the B-side ZT-M1. Beside the B-side, gotta love it. And don't forget, this B-side is also known as the NA-V8. So I think this is a pretty fair comparison. Already starting off at half a volt, 0.572, and they're both looking good. Here we go. Starting out to a whopping 5.9 volts, showing us 5.997, 5.997, 6.0. Wow, they're pretty close. Let's take it up a notch. Let's go to 8.6 volts. 8.681, 8.67. Slightly better resolution on the Q1. Remember, the Q1 is a 10,000 count, and the ZT-M1 is 8,000 count. Already taking it up to 16.4 volts, 16.54 for the NA, 16.55. Hey, look at that! They agree totally. Up and away, 22.4 volts. Gonna settle at 22.50, 22.49. Oh, they're so close. Look at that. Now they are right neck in neck. Gonna max it out now at 31.5 volts, 31.61 and 31.61. Oh my gosh, this is so close. Wow. Wow, all these voltage comparisons I've done, and I tell you, this is really probably the closest. So definitely they are neck and neck. Good stuff. All right, we are now in low current mode, milliamps to be exact, and we are sitting at 15 milliamps. Now let's see, this has a really nice 800 milliamp range. Gotta like that, lots of room for playing. Here we go, taking it up to 120 milliamps, no worries there. And we're gonna go right up to 420 milliamps. And we can see that bar graph as well, the 420 mode. And we are now at 650 milliamps. Yeah, looking good, looking good. Okay, and we're gonna go higher, 690, 700, 710. 810. And we're showing at 769. I'm going to bring up the voltage here. Alrighty, 800 milliamps. And, well, we are right at the cusp. What do you think? Should we continue? Why not? Let's live on the edge. And go a little bit higher. Take it up to 840, and we are OL. Let's bring it back down. 800. No worries there. So, yeah, we can get just over that 800 milliamp range before we are OL, which actually means out of luck. Oh, God, I'm funny. Not really. Alrighty. Presently, we are in current mode, sitting at 6.1 amps. Been on here for about 10 minutes now, and it has not swayed at all, so all looks good. Next up is a high voltage test. We're going to put this up to about 1,200 volts DC, and let's see first of all if it's capable of reading that high of voltage, and secondly, is there an alarm when we over voltage. So here we go. So there we are, no problems. That was up to about 979 volts. Try that again. 978. Okay, so I'm going to take it over 1,000 volts now. And we do have an alarm. We have a high voltage alarm. Now, interesting enough, there is no symbol coming up on the EPTN screen, but it is at least giving us that audible alarm. Try that one more time. And there we go. So over 1,000 volts. Doesn't like it, and it lets you know. Continuity time. Here we go. Default test leads. Really liking these leads thus far, I gotta say. But this is the crux. How are they at continuity? Okay, let's put it into continuity mode. Always a good first start. And let's see what happens. Oh, fingers crossed. I hope these are great. Hey, I'm liking it. Yeah, it's missing probably 2 out of 10, but overall, not bad at all. Yeah. Next up, it's Pro Masters. You saw that coming. Here we go. Wow, perfect, perfect. And you see that audible as well as the visual indicator. I love when they add that extra LED. You never know, it's going to be super busy. Maybe you're in an industrial setting and you won't be able to hear that meter, but you can definitely see the continuity. Good stuff. Continuity reading in decibel mode, 70.1 decibels. So we are checking out the temperature mode. Now this is really nice. It has that dual display, so you've got your Fahrenheit now on the top as well as the Celsius on the bottom. And just for comparison purposes, I have this infrared thermometer here. And yeah, it's pretty darn close, 20.7 showing on the thermometer, 21 on the B-side. And if we go over to Fahrenheit, 69.2 showing, and 70 on the B-side. So the other thing worth mentioning is you don't need this thermocouple by default, since the sensor is actually on board of the PCB. Only will you acquire this add-on if you want to measure the temperature of boiling water or freezing water, what have you. But yeah, generally speaking, if you just want ambient temperature, no probe needed. Currently in volts AC, let's plug it in. And 121 volts, 60 hertz. The frequency looks good. Really nice to have that dual display set up in one easy glance. And if we hit the VFC mode, we're not going to see any difference. But if you're working in HVAC or on a compressor, what have you, that will definitely help. It acts like a low-pass filter, and it will give you proper voltage readings. Meter is now in NCV or non-contact voltage mode, and it is looking for an electrical field. Let's see if we can give it one. So you see the LED is starting to emit. Probably not the strongest NCV antenna that I've seen, but yeah, it seems to be doing the job. Finally, if we take a look at the flashlight, it will stay on permanently until you turn it off. Nice and bright, and always decent to have a flashlight in your multimeter. At least that's what my grandma used to say. We are currently in resistance mode on the low side of things. Let's start off with 1 mega ohm, looking good. 5 mega ohm, no problems there. 8.55 mega ohm, yeah, it's pretty darn close. We're now in signal generator mode, and you can see we have a pretty decent looking square wave, and we're presently at 50 hertz. Next up, we'll check out the drop-off voltage of the ZT-M1. So we're sitting at 4.5 volts right now. Let's start taking it down. Let's see what happens when those batteries begin to fade. 4 volts, 3.8 volts, still all is looking fine. Going down further. No fading yet, 3.5 volts, so a full voltage lower. And we are still looking good. 3.3 volts. 3.2, 3.1, 3 volts, 2.9. Now the fade, the screen is slowly starting to fade. 2.8, 2.7, and there comes the low light battery indicator. And really, at this point, the screen is basically unusable. 2.5 and 4, and yeah, you can't see a thing. So basically, it started to fade at around the 3 volt mark. Still usable till around, I would say, 2.9, 2.8 volts. Verifying the battery life with the BSIDE ZT-M1, we're pulling in around 0.85 milliamps. Now, if you're utilizing your standard AA alkaline batteries, that should equate to about 300 to 400 hours of battery life. Not too shabby for such a nice display. Starting at the bottom, we do have, on the milliamp side, that 800 milliamp, 250 volt ceramic fuse. Now this is the awkward, tiny variety. I don't know why they do this. It would have been really nice to see the implementation of the same size fuse as the high current. But alas, it is not to be. We are stuck with this little dwarf PIA. Alrighty, so with the current side, we do have a standard size, 20 amp, 250 volt fuse ceramic. Input jacks are right here. They are a better filament than the last few I have seen. They are of the split variety, but no worries here. They're being retained in part by the front and back of the casing. So all in all, it makes for a really nice, tight, solid fit. No worry about getting loose with the input jacks. In terms of the actual input protection itself, on the high current side, we have the one ceramic fuse, as well as that current shunt. And we also have up here a diode clamp going on. This is all for the current side, the high current. For the milliamp, strictly speaking, all we have is that milliamp fuse, no other protection on the PCB itself. And for the voltage, we have one lonely PTC, yes, standing between you and your destiny. Definitely you want to keep this off anything really high mains, because let's face it, protection wise, it is not so great. The brains of the unit is right here. That's the DreamTech International ZT-M1 and that is a very nice IC. It does all of the ADC conversion as well as the LCD driver and more. The config data for that guy is located right here on this tiny EEPROM. Now normally you'll see the DreamTech ship with a T24, which is a 2 kilobyte EEPROM, but that is not the case here. Instead, they've decided to go with this NEC EEPROM, which is storing all that config file for the DreamTech. Over here is another IC, but it has been completely whitewashed. No markings on it whatsoever. At the top here, we have the NCV, or non-contact voltage wire. And here are with the piezo, and this is finally the diode for the continuity and NCV mode as well. In the middle, of course, is that ever so bright LED flashlight, but that is basically it. Fairly sparse, quite clean looking, not a whole lot going on here, but at least it's a nice clean board. There is no shielding in the back of the unit. And of course you have that gorgeous EBTN display, and that is just sort of clipped on there. It's being retained by two Phillips at the top, as well as those clips on the side. Feeding the power, you've got the two small wires here that connect directly to the PCB. Might be hard to see, but there's a lot of grease on these tracks, and I mean a lot. Wow. So that's probably a good thing. It's going to definitely help with the wear and tear over time. Other than that, if we look at the bottom here, you can see there is a bit of flux on the fuse insert holders. A little so-so in terms of the overall soldering, but not that bad, really. Okay, I'm going to put everything back together. Come back with thoughts on the BSIDE ZT-M1. Wow, this is a hard one to call. I really wanted to like this meter, and I wanted to like it a lot. That being said, there was a few things that just really bothered me. One of them was the overall build quality. I just didn't feel like I was getting my money's worth. It just feels really cheap. The boot, once you take it off, it had this well, I'm sorry, but that's the truth. Yeah, it has this very, I don't know, just a cheap feeling. And once again, it's like $60 to $70 Canadian, about $45.50 US. So, you know, I was expecting more in the quality build department. Also, the input protection was lacking. I was expecting a little bit better as well. Now, that being said, this meter does do some pretty cool things. We're talking auto ranging, manual ranging. Hey, there's not many meters that do that. It's very neat feature. Also, that gorgeous EBTN display and that fast bar graph. It's really hard to beat. It's a really it's a hard meter to gauge, but you know what? I'm going to give the BSIDE the benefit of the doubt because they're definitely thinking out of the box, and that's a kudos from me. I'm going to give the BSIDE ZT-M1 a solid 3.5 out of 5 stars. There. Well, I'm sorry. I did the best I can. Hey, I hope you enjoyed this review, everybody. Keep those comments coming. Give me a thumbs up. And if you want to see a meter reviewed, let me know and I will do my best to review it. Till the next time, keep on testing.